Alright, period 2. Sorry that I am not here again today. I am actually in a meeting that I did not find out about until yesterday. So what I'm going to do before you take your quiz today is to just work some of the homework problems that you may have had questions on from last night, and hopefully that will help you. The assignment for tonight will be posted. We're just kind of staying with the same chain rule, not doing anything new. So anyway, let me just start working some problems, and after you look through these problems or view this, then you'll have about a half hour to take your quiz. So here we go. I'm going to start with number 49. I'm just going to work as many of these as I can. In problem number 49, you are given the function y equal to e to the 2x, and you're asked to find the slope of the line tangent to the graph at the point 0, 1. So in other words, they want us to find the derivative at x equal to 0. Notice that this is an e function, so remember when you find the derivative of e to a power, it's e to the power multiplied by the derivative of the power, and in this case the derivative of 2x is 2, so if we clean that up a little bit we get 2e to the 2x, and we're evaluating that at 0, so y prime of 0 is equal to 2e to the 2 times 0. Remember, e to the 0 is 1 and 1 times 2 is 2, so the derivative at 0, or the slope of the tangent line at 0, is 2. Moving on to number 55. Number 55, we have been asked to find the derivative of y equal to cosine of 3x, and in this problem, I'm going to move this toolbar over so I can change colors easily. There is an outside function of cosine and an inside function of the angle itself. Now this could be thought of, it's not written that way, but we're literally taking the cosine of an angle, so the inside function is the angle itself. When we find the derivative, we're going to take the derivative of the outside, and the derivative of cosine is negative sine of the angle multiplied by the derivative of the inside, and the derivative of the inside is the angle itself, and the derivative of 3x is equal to 3. So we get negative 3 sine 3x, and that's our derivative. And if I make any mistakes in these problems, feel free to let me know later, but I'm just going to go as fast as I can and get as many done as I can. Problem number 57. In 57, we have g of x is equal to 3 tangent 4x, and this is very similar to the last problem, except for now I have a coefficient out front. The outside function is the trig of tangent, and the inside function is the angle. And again, if it helps you, you can put parentheses around the angle. The 3 is a coefficient, and it's just going to come along for the ride. So when we find the derivative of the outside, there's my 3. The derivative of tangent is secant squared of the angle. All of that's the derivative of the outside, this part right here. And the derivative of the inside, which is the angle, is 4. And so cleaning that up, we're going to multiply the 3 times 4 and get 12 secant squared of 4x. And you don't have to put those parentheses in that last step, but this is what the answer would look like. 59, let's see, what did I ask you to do? Yep. In number 59, we are finding, we've got f of theta. Make sure you use the variable theta. Now notice what I'm going to do here, and I think I did this incorrectly yesterday, but nobody caught it. When I am moving that square on the sign to the outside, the coefficient of 1/4 is not included because that does not have the power. And I think yesterday I did one, and I included the coefficient on the inside of the parentheses, so check your notes on that. Alright, so here we go. The 1/4 is a coefficient. We have the outside function, which is the power of square. We have an inside function of the trig, and then we have an innermost function of the angle to theta. So this is a chain with a link of 3 functions. So I take the derivative of the outside. So when I use the power rule up here, The 2 times the 1/4 gives me 1/2 of that quantity to the first power. So that is the first, all of that right there is the derivative of the outermost function. So I'll number that as number 1. Now I move on to the trig function. The derivative of sine is cosine of the angle. So all of that right there is when I take the derivative of the second function. And then finally, the derivative of the angle 2 theta is just 2. And so that's number 3. So cleaning that up, all I'm going to do is take this 1/2 that is in the front multiplied by the 2 in the back. Half of 2 is 1. And so I get sine 2 theta cosine 2 theta. Now when you look in the back of the book, they're going to have the answer written differently. This is an identity that you were taught, supposed to have learned last year. This is the same thing as 2 sine theta, oops. No, it's not. Sine of 2 theta. This is perfectly fine. Now they may use the identity and rewrite sine 2 theta as 2 sine theta cosine theta, but this is perfectly fine. You don't have to know that for this problem. So if you see the different answer in the back of the book, that's what's going on. All right, let's take a look at number 61. In number 61, we have y equal to, I'm going to go ahead and change that square root of x to the 1/2 power plus 1/4 sine of 2x to the second power. Now notice in this problem that the square is only on the angle and not on the trig function. Now if you're smart, you're just going to rewrite that as x to the 1/2 power plus 1/4 sine. I'm actually going to square the 2x and get 4x squared, and then I take care of that. Now when I find the derivative of the first term, I'm going to use the power rule and get 1/2 x to the negative 1/2 power. When I find the derivative of the second term, sine is the outside function, the angle is the inside function. The coefficient of 1/4 just comes along. So when I find the derivative, there's my coefficient of 1/4. The derivative of sine is cosine of the angle multiplied by the derivative of the angle, which is going to be 8x. So when I clean that up, I get 1/2 x to the negative 1/2. The 1/4 times the 8x will give me 2x cosine 4x squared. All right, let me look ahead and see if there's anything. I want to make sure I get a pretty good representative problems here. So I asked you to do through 71. Yeah, let's go ahead and do number 63, and then that will bring us to the E problems. 63, we have y equal to sine of parentheses cosine of x. So I think you can see here that the outside function is sine and the inside function is cosine. So when we find the derivative of the outside, the derivative of sine is cosine of the angle. So all of that is the derivative of the outside multiplied by the derivative of the inside. The derivative of cosine is negative sine of x. And there's really not a whole lot more I can do to that except stick the negative out front and make it cosine of cosine x times sine x, and that's multiplication, that's not a minus. And there's really nothing more that you can do to clean that up. You can't do anything with the cosine of the cosine. It doesn't become squared, it doesn't do anything like that. Now if you have other questions on these problems, you know you can come and see me at lunch. I will be in room 312 today at lunch, barring any other emergencies. 65, we're down to the E problems now. So we have f of x is equal to e to the 2x. Remember, when you find the derivative of e to a power, it's going to be e to that power multiplied by the derivative of the power. Since the power is 2x, the derivative of 2x is just 2. So that's an easy one. 67, If I play my cards right, we'll get all these done. I have y equal to e to the x to the 1/2. Now notice that was the square root of x, and I went ahead and rewrote it as a power. When I have the derivative of e to the power, I get e raised to that power multiplied by the derivative of the power. And since the power is x to the 1/2, the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So my final answer, in cleaning it up just a little bit, would be e to the square root of x, and I don't care if you leave it written as x to the 1/2 power, over 2 square root x. 69. In number 69, we have g of t equal to e to the negative t plus e to the t to the third. All right, so we have an outside function of e to the of the third power, and the inside function is the quantity. So be careful when you find the derivative here. We're going to use the power rule. So we bring down the 3. There's the quantity to the second power. Bring the inside along. Now notice when you find the derivative of the inside, remember we talked about the derivative of e to a power is e raised to that power times the derivative of the power. And the derivative of negative t is negative 1. The derivative of e to the t, that's our favorite function of all. We get e to the t. Nothing can combine. These guys they're not like terms, because this is negative t, this is positive t. There's nothing else that you can do but leave it alone and put it in the blank. Number 71. In number 71, we have y equal to ln of e to the x squared. And when you're looking at this problem, you should be thinking, we don't know how to find the derivative of ln's yet, but you apply a little bit of algebra here. Remember that the base of an ln is e, and so these two functions, ln and e, basically ln and e undo each other. They don't really cancel. I know you guys like to talk about canceling, but they really undo each other. And this is really the same thing as a fancy, sneaky way of saying find the derivative of x squared. And of course, you know that the derivative of x squared is just 2x. So that was a sneaky way to ask you to do a really, really simple problem. All right, let me look at 101 and 103, and then you guys will get working on your quiz, and I know that you will do well. And these trig ones, of course, are not on your quiz today. We're finding the second derivative of this function. So we have 2x squared minus 1 to the third power. So the first derivative of this, using the chain rule, would be 3 times 2 is 6 of the quantity to the second power. That's the derivative of the outside, times the derivative of the inside is 2x. Cleaning that up, I'll get 12x times x squared minus 1 to the second power. And now when I find the second derivative, I have to use the product rule. Now this will help you for your quiz today if you focus. So when I do the product rule, let me move this up, I'll have the first function, 12x, times the derivative of the second function, and this is where my power rule is going to come in, 2 of these to the first power times the derivative of the inside. So all of that is the first times the derivative of the second plus the second times the derivative of the first, which is just 12. And I'm getting ready to run out of time here, so let's clean that up. 12 times 2 is 24. X times x is x squared. I just saw another 2. Times this 2 will make 48. I'll write that better. Let's do 48x squared times x squared minus 1 plus 12 times x squared minus 1 squared. And yes, we could distribute this, but I'm running out of time. But the big idea is that when you found the first derivative, it was chain rule only. And after you found the first derivative and you cleaned it up, you had the product rule and a chain rule as well. Okay? So do well on your quiz. If you need to see me at lunch today, I will be available. Have a good day.